K4ZA. Don is a tower professional, and he is the author of the ARRL publication, Amateur Towers for Radio Amateurs. So we welcome you, Don, and please go ahead. It's all in your hands.
All right. I assume we see the slides, or the slide, right? The title slide. And I assume you can all hear me okay.
That's
Yes?
Yes.
Okay.
Yes.
Sparky.
All right, good. All right, well, I'm honored to have been asked to give the talk. It's a little frightening because I've never done a Zoom talk before. And already I see that somehow the next slide is blank, which is very weird. But anyway, as you saw there, I'm using your title. It was not my title, but you wanted to focus on safety in all aspects of ham radio towers. So basically what we're going to talk about, or what we'll have here, is some observations from over 50 years of doing tower work. I put up my first tower when I was 15 years old on the family farm. I put it up, I dug the hole and poured the sackcrete on Saturday evening after the chores were done, and then Sunday evening after the chores were done, I actually stacked 30 feet of tower, as silly as that sounds. Interestingly enough, the tower, I noticed that I was back to the family, drove by the family farm 2 years ago, and the tower was still standing. Didn't have anything on it, but it was still there, which maybe means that I did something right. Anyway, we'll talk about some things that you should do. We'll talk about some things that you should avoid, or as those of you who've been in the military, heard of the 4 Ps, which is planning prevents poor performance. So what are we going to talk about again? We'll talk about some things that can save you some time and some money. Many of you probably know them. You might have forgotten them. We'll talk about some techniques that just might save a life. Again, we're talking about safety, or at least an injury. And I'll share some things that I often see doing this tower work, quote unquote, professionally. That means some do's and that means some don'ts, or common mistakes and how to avoid them. Safety is often taken for granted by hams, or it's not even considered at all. But you should remember that no job is so important that it has to be done in an unsafe manner. And you should never rush when you're doing tower work or doing an installation. There's really no call for that. We don't have, a government institution or agency like OSHA looking over us, but that still means that we have to think about safety. It's up to all of us, if we're going to do tower work, to learn, understand, and follow safe working practice. The party you hired or you've experienced, are they knowledgeable? Are they insured? That's a critical thing. I personally have $3 million worth of liability, which is always an interesting experience. I've been licensed for 58 years. I find that sometimes hard to believe. I mean, I know it's not necessarily a long time, but with some clients it is, and that's okay. But during that time, I've gained firsthand experience in building, erecting, or preparing almost every tower and antenna type that's out there. I can't think of anything I haven't really worked on in terms of towers. I'm a guide tower guy, not a crank up tower guy or a self-supporting tower guy. But all that experience is valuable. It's a real marketing advantage, and it represents true value for today's customer. Before we get into hardware, let's talk about actual climbing process itself. The key word, of course, when you're talking about climbing is connectivity. Being hooked up to the tower 100% of the time. That means the PFAS, a personal fall arrest system. It doesn't mean the old lineman's belt, from 1970, that sort of thing. It means the PFAS, and there aren't any exceptions. Here's a PFAS, and that's the DBI Solace system. It's probably used by about 90% of the tower climbers professionally. It's really something like a standard of the industry. If you take a look at it, you'll see that there are 2 sets of D-rings at the waist. The lower set, of course, are designed to be used for the safety, and the higher set, the sets that's connected to the belt, are designed for the work positioning lanyard. There's also a D-ring in the center of the back that's used again for the PFAS system. Those are the big gorilla hooks, and usually there are two of them, a left and a right. It makes climbing or climbing up or down slow process, but again, you're connected 100% of the time. There's also some things, other things that we should consider here. Typically clothing, hard hat. I can't tell you the number of times I get to jobs and I have to, reach in the truck and hand out hard hats to people. You got to wear gloves. I insist on that. Long sleeve shirts, always a good idea. Jeans, a good idea as well, even in hot summer heat. Although, of course, on a 95-degree day here in the Carolinas with 100% humidity, I'll be wearing shorts and a t-shirt. Boots, of course, another thing for the climber to consider. Something with quote unquote shank insoles, because obviously if you're going to climb something like a 25G, that little 3/16 horizontal is tough on your feet. Hydration is another consideration, and it's talking about both the climbers and the ground crew here. I'm not talking about beer. We're just simply talking about things like water and or Gatorade, et cetera, et cetera. Ropes and tool bags and having spare, also another serious consideration. And of course, the most important thing probably is what's called the tailgate meeting. It takes place before any climbing or work is done. What that means is you just simply lower the tailgate and the pickup, and you sit there and you go over everything for everyone so that everybody knows the scope of the work, who's responsible for what aspects of that work, the predicted sequence of the work, i.e. what's going to happen when, where things are found, and what's expected to be accomplished that day. And of course, you always want to talk about potential problems or issues. Let's consider some things that I've encountered in this work. Let's start at the tower base. This is an example of something that I encounter all too often. This is a Roan 45G tower right here in Charlotte. Was put up and not inspected or looked at much for 28 years. And of course, with the base below grade, i.e. that means that if you walked up and looked at the base, there would be no concrete above ground, and the tower leg, is basically below ground. And when you mow the lawn, all that debris collects there, and dirt and debris and so on. And in 28 years, the 45G just simply dissolved completely. Now, you only got two options on some case like that. You can get a crane in to take it down, or you can build a form and pour concrete around it and, save it that way. But I encounter this all too often. Another thing I encounter is using hardware store items for things like tower guide. And this is a perfect example. Whoops, whoa, we didn't want to do that. This is a perfect example. What's wrong with this? Well, if you can look carefully at the ends of that turnbuckle, you'll see that the eyes are simply rolled. And I'll never forget N4UH one time called me in a total panic. One of his guy wires had suddenly, he's told me, was missing. And I said, well, Henry, it's impossible. I mean, unless somebody climbed up and took it. But he said, no, it's missing. And anyway, I got up there, and it turned out that the turnbuckle had simply come unrolled. And it was Philly strand guys, and it had blown up into an oak tree. But anyway, believe it or not, a turnbuckle can come unrolled. Another aspect of things you sometimes find is hardware store items, which is not load rated. This is what's called a chain quick link, meaning that it's not load rated. It's not meant to have people, lives depending on it. So it's dangerous, and you never want to encounter them in tower work. Thimbles and shackle examples. This is one of those things that I encounter probably, in fact, this is probably, the thimble one is probably what I encounter more than anything else. And we're talking about something like this. But the top picture is a 1/4-inch hardware store rope thimble on a 1/4-inch EHS. And as you can see, it does not fill in the preform line product's big grip eye. Below it is a properly sized heavy duty thimble, 7/16 of an inch on the 1/4-inch EHS. If you look at that top one again, you'll see as you tighten that EHS up, or you tighten that guy wire up over time, it will the eye will simply collapse because there's no thimble to pull, prevent that from pulling in on itself. So I encounter this problem. This is the biggest quote unquote mistake I probably encountered. The other thing is, of course, not everybody is a believer in using Freeform line products, big grips. Some people are still using quote unquote cable clamps. And here's a simple correct and incorrect way to do it. I personally haven't used these for 30 years. Most of the time when you do encounter them, if they're 30 years old, they're rusted shut, and so you have to cut them apart. Anyway, some first steps before we start thinking about permits even. You need to think about designing your system. You're developing a station system, a plan. Your concept, your design, whatever you want to call it, along with your realistic budget. And of course, you have to think about, are you going to do single op operating? Are you going to do multi-single? Are you going to do multi-op? Are you going to do multi-multi? SO2R, SO3R? Are you a big DXer? Do you want a contest? Do you want a rag shoe, VHF, etc.? If I told you, and the number of times I get emails or calls from people say, I want to put up a tower, how much is that going to cost? And then, of course, we have to play devil's advocate and come back and start with questions like this, because all these things are the first steps you should take. Permits. Always assume that a permit is going to be necessary or required, and you proceed from there. Personally, I really like K1, Fred Hopengarten's book, Antenna Zoning for Radio Amateurs. It's available from ARRL. I have had numerous clients. I've recommended it to numerous clients. Those clients have most of them all have followed Fred's guidelines, and absolutely every single one has gotten the permit or the request that they wanted. You need to remember to be friendly and positive in every interaction with the public officials or your neighbors. You go down and talk to the people in the zoning office. 9 times out of 10, they will have no idea what ham radio is, period. I mean, they're going to think it's a broadcast antenna. They're going to think it's something to do with cell phone towers, et cetera, et cetera. And, it's real easy to get short and kind of uppity with them because they're so stupid or uninformed, but you can't do that. You got to remember that you want to be positive in every interaction with them. Remember, you're not putting up a tower. It is an antenna structure. All right, when we're putting something up, the question of used versus new always arises, always comes up. People ask me about this all the time. You have to know what is or is not a bargain. How do you do that? Well, of course, you can check current prices on qth.com. You can go to eham.net, or you can seek advice from a professional or an expert like me. And it's no problem using used equipment or used gear because we're not all millionaires. New is nice, but being practical is okay too. If it seems the deal is too good to be true, it probably is. Some of the errors, of course, that happen. You assume too much. Hardware always has physical limits. Towers, the mast, the rotator, hams often overload them. Let me repeat that. Hams often overload them. Larger antenna design should have PE analysis and approval, or again, talk to somebody like me who's done this for a couple weeks now and can understand what's going on. You should never underestimate Mother Nature. What that means is the question you have to ask yourself, does one really build for ice and or wind? The answer is yes, but the outcome is always uncertain. And the reason that that's true is you can design the antenna to support that ice load. But it's when the ice load comes off the tower and or the antenna, you get into trouble. For instance, WRAL up in Raleigh, big station, they lost their brand new tower because the ice came off the tower to the east side where the sun came up. And of course, the tower was now overloaded on the west side significantly, and it came down. So again, the outcome is always uncertain for ice loading. All right, let's talk about the tower itself. And you should think about planning how many towers or antennas that you want, how many you're going to need, or how many you can afford over time. You should think about the future. Your interests and your circumstances will quite often change. Size matters, of course. We've all heard about that. Bigger is better, right? Wind load drives the tower design and the materials required. The budget cannot govern the physical limits of that tower. You should always comply or follow the manufacturer's guidelines and installation instructions. For instance, the BX series towers, they specify right in the directions. You don't put anything up with a longer or larger than a 10-foot boom. I recently had a guy who wanted to put up a C31 on a BX56. Hardware. It's pretty simple. You get what you pay for. You should always purchase properly rated materials and components. In other words, don't buy junk. Let's discuss that hardware in some detail now. And I mean by hardware, the guides, the turnbuckles, the thimbles, shackles, nuts, and bolts. There are three choices and only three choices for guying materials. They are, of course, EHS steel, Philly strand, and/or polygon rod. You don't use plastic covered clothesline cable, baling wire, TV hardline, black Dacon rope, or any kind of rope, does that matter, for tower guy. And I list those things because I have encountered every single one of them. And the hardest one to accept was the TV hardline. It was I drove up to the guy's place. He called me up and asked me, he says, I understand you take stuff down for salvage value. And I said, yes. He said, I got a Shorty 40 and a TH7. I said, yeah, I can probably resell that. We can do that. I can take the stuff down. Drove up. As we drove through the driveway, I looked over and I said, the guys are black. This is great. It's probably guyed with Philly. But when I got there, I discovered that it was guyed with TV hardline with polyethylene jacket. Aluminum TV hardline. Needless to say, we didn't climb that tower. Preforms, of course, are the preferred choice for all three of those things, the EHS, the Philly strand, or polygon rod. They're again, they're the preferred method. Not only are they much faster to use, they're much more durable. They don't rust away. Antenna truss material, if you're putting up a big beam, you should probably consider changing to Philly instead of using steel or rope. I do that almost every job. Turnbuckles. You should use only heavy-duty galvanized turnbuckles, hot dip galvanized. Size matters, again, longer is better. Oh boy, that's provocative, right? I prefer 12-inch long, half-inch diameter length. I prefer either the eye to eye or eye to jaw, depending on the situation. Chinese hardware works well, and it's significantly less expensive than the Roan equivalent. I've been using it for over 30 years, and I've never had one issue. Use quality galvanized turnbuckles up top on that antenna truss cable as well as also. You don't need to use the half-inch diameter, but again, galvanized turnbuckles up there. Thimbles and shackles, we've talked about them. Again, these are all items that drive not only, using the right thing to be safer, but they're items that are often misunderstood or overlooked. Again, HD thimbles. You don't use rope thimbles found at the local hardware store. In fact, there's hardly anything you can find at your local hardware store that's quote unquote suitable to use for tower erection. You don't hammer the thimbles onto your turnbuckles or the EQ plates. You use a shackle to make that connection. And you always try to use anchor shackles. The screw pin style is preferred as it's the easiest to work with. Use one at each guy bracket, the EQ plate, and the turnbuckle. It makes life immeasurably easier should you ever need to, quote, change anything down the road or later. Now, you can also use NicoPress fittings if you have the fittings and or the tool. Here's a truss support and a NicoPress example on a Monster IR from Stepper. The mast. Steel tubing is specified for many installations. That means 4130 chromoly tubing, or DOM drawn over mandrel tubing. Aluminum tubing is all right as well, but you want 6061 T6 alloy. 1/4-inch wall is the minimum thickness, 3/8 or 1/2-inch wall is preferred. Water pipe, well, I'll admit in 1970, I used water pipe myself, but it's no longer 1970. So unless the load is literally going to be just inches above your thrust bearing, don't even think about using it, despite its cheapness. Water pipe is made from old car tires, washing machines, and so on and so forth, and does not have an ASTM rating typically. So, it's designed to carry fluid from point A to point B. It's not designed to be up overhead, facing Mother Nature. Truss bearings. Here's some FAQs. This is the Roan TB3 bearing. And you should see these a lot. You'll encounter these a lot. And of course, you'll encounter a machine shop bearing a lot if you put up or encounter crank-up towers. The crank-up folks are still supplying machine shop bearing. The TB series is pretty lightweight. It's aluminum. It's inexpensive. It's designed to carry the typical ham antenna load. But there are some possible issues. You can see that the case will crack sometimes. That's rare. That's a sign of overloaded design or improper installation. You should always replace the Roan collar bolts with stainless steel bolts to mitigate similar metal corrosion. It's not at all uncommon to climb up after 10 years and find those collar bolts frozen or rusted into place. Metal migration is another issue. The steel bearing on an aluminum race, if you have a big antenna, i.e. something like, and this is very common at contest stations, where they build a big antenna, but it's used 4 times a year. The rest of the time, it remains parked in one position for long periods, and you'll get what's called metal migration, where the wind will rock that antenna slightly back and forth, and eventually those steel ball bearings, which are much harder than the aluminum race, will create a divot in the aluminum. And if you're using something like a cam 4 or a tail twister, that divot can become large enough that the antenna will no longer rotate. And that's a real fun issue, especially at 100 feet. So there's an answer to that, and it's what's called the new TB300 or the TB400, 2-inch and 3-inch sizes, typically, from DX Engineering. They're a decided improvement over the original Roan bearing. If we had these two quote-unquote bearing pictures side by side, you can see that the DX Engineering bearing is more of an axial quote-unquote design. If you go to their webpage, they have some cutaway versions where you can look at that and see where that's the case. Really nice bearing, a little pricey, but boy, big improvement. Here's what I was talking about earlier. This is a before and after shots of what's called a machine shop bearing, which came off a 50-foot crank-up tower. Picture on the left is it had been in place for 12 years. The owner had just put it up as is, i.e. as he got it from the power company. It wasn't too bad. It was pretty rusty, but it wasn't too bad. They have an Allen set screw on that collar. It's often a problem. It rusts into place. Of course, the bearing has, as you can see, it has a Zerk fitting on the right-hand side on the back. You can see it more closely on the bottom there. This is a sample or an example of where we took some Rust-Oleum primer and then some top coat, and then we've covered it up pretty well. Head bolt again to prevent the collar, and then some nice, new grade 8 bolts on the outside, and filled it up with grease and put it back up. I was on that tower 2 years ago, and it still looks pretty much like this. So, unless you do this, you're going to be facing the top picture. Okay, nuts and bolts. Here's an issue that a lot of people have no idea about nuts and bolts, don't know much about them, but there's a lot of choices. Of course, there's hot dip galvanized hardware, there's stainless steel hardware, then we've got split washers versus a nut versus a nylock. You know, there's something called proper tightening techniques. And then of course, there's people that say you got to use anti-seize on everything. It's the same as steel. But of course, most people don't realize that using anti-seize reduces the torque characteristics of the hardware themselves. So again, this is a talk. I could talk for a couple hours on this. Obviously, I suggest you do some research on Google on this one. Here's a chart. We'll not spend a lot of time on this, but again, you should be able to identify hardware just by looking up here at the bolt heads. What to do on installation day? Well, after completing your design and you've gone out, you've bought the materials, the work is going to begin. Well, who's in charge during tower work? And the answer is really very simple. It's always the climber, the people whose lives are quote unquote at risk. We've already talked about this. You should have a work plan. That's something you're going to talk about during that quote unquote tailgate meeting. But I'm a huge believer in pre-visualization, meaning how tasks should be done, the task order is needed, et cetera, et cetera. You want to ensure, again, during that tailgate meeting that all of your helpers know the plan before anyone climbs. You want to discuss safety issues. You want to anticipate what can possibly go wrong and what to do if it does. Having mentioned a ground crew, let's answer this question. What makes a good ground crew? The real simple answer is the best ground crew is always the old retired climber. I'm about to that point myself. Anyway, you stage and organize all the needed materials and tools near the base of your tower. You listen, you promptly follow the directions given by the climber. Again, they're the ones whose lives are at risk. They're in charge. Everybody at that ground crew level is going to be wearing a hard hat, and you want them to have work gloves on. If you're going to be a ground crew guy, it's your job to stay alert, pay attention. You want to anticipate the needs of the climber. That's sometimes hard, but if you're a retired or an old fart climber, it's pretty easy to do. It's definitely not the time to be looking at your phone. Let's talk about dealing with Mother Nature. Believe it or not, this is a photograph I took for a client job in Chicago, near Chicago. And the client really expected me, you can see the tower, it's 100 feet of 55G, really expected me to deal with this. And I hope some of you are laughing, or maybe some of you are just going, what the hell did he possibly do there? And the answer is, of course, we just had to cut down a lot of trees. It was an interesting job. All right, want to talk about tramming. Tramming is a really very misunderstood word or misunderstood topic. It simply means installing a single dedicated line or rope on the mast or the tower upon which the antenna, the load, rides, pulled aloft by a separate rope. The antenna rides on a pulley that's often turned upside, it's always turned upside down on that rope, or something like Tetzel's double sheave pulley. That sounds pretty easy, right? Well, rigging for tramming takes time, but the results are worth the effort. Once you've done it successfully, you will not want to not tram. If you absolutely positively cannot tram something up, there are, of course, options. You can corkscrew the antenna into place. You can do a deadlift, i.e. straight up, or you build the antenna in the air using a PVRC mount. For example, in that antenna, which is an Optibeam 21 element thing, by the way, there in the middle of that forest, that's exactly what we did. We pulled it. Once we got the trees out of the way, we simply deadlifted it, pulled it straight up the 55G tower. We took all three guys, two sets of three guys off the tower and pulled it straight up the tower. The client was having a heart attack, but it worked perfectly, as it always does. Here's the secret, one of the secrets to tramming, that Tetzel double axle pulley. It makes things stay in line, quote unquote, much more easily. Dynamic balancing the antenna is another secret to tramming. And this is an example of high gain 105 at 5-element 10-meter Yagi. And what dynamic balance means is if you click the antenna up at the boom to mast plate, i.e. right in the center, the antenna hangs plumb or level. And it's very easy to do. You go to Walmart and you buy a fish scale, $4. You have to figure out how to lift the antenna up so that it hangs. And then you go to that end that's hanging down, hitting the ground, put the fish scale on it, pull down, get it, balanced, i.e. level or plumb, and read off the scale. And it says 4 pounds, and that means in that end you need to put, quote unquote, 4 pounds of weight. Now that's easily done because you can use, galvanized water pipe. This is a 2-inch boom, so 1.5 inch water pipe. You can look up the weight, cut the few inches off, put a stainless steel bolt through. In this particular case, we didn't need much weight on the 105. And actually what that is there's a little bit of ground rod, and it's held in place with polyurethane expandable foam. Then we covered it up with the end cap, and everything was fine. Here I am corkscrewing that 105 around the top set of guys at K8 POs. Here's some more corkscrewing. This is K4ZA's 20-meter Yagi into position. Or you can work with mechanized help. And this is a scary, expensive, and dangerous proposition. People always throw up their hands, ask a lot of questions, run around whirling dervish style, but it's actually kind of fun. It's possibly cheaper than doing things the old-fashioned way, a stick at a time, and it's certainly much safer. And it's sometimes necessary. For example, it's necessary here. This is a 3-element 80-meter Yagi at K9CT, which, if memory served, was 627 pounds. That's not going to tram up, I don't care who you are. Or in this particular case, this is installing a 45G tower in two picks, 180 foot and another 80 foot. Cranes, of course, are part of that mechanized help. They're just like a tower. The first rule is you have to watch out for the power lines overhead. You have to consider the weight of the crane on the driveway or the ground. You have to ask for a site survey. Most of the time that's done by the crane company free of charge. That resolves almost all the questions concerning access, safety issues, and general applicability to your job. It's also important that you do it because the crane guy probably 7 out of 10, 8 out of 10 times isn't going to come with ham radio experience. They're not used to doing things like lifting a little 100-pound antenna up on top of a tower. They're used to lifting things like HVAC equipment on the roof of a building, which weighs, a couple of tons. So the site survey is vitally important. There's some advantage, of course. There's some disadvantages, of course. The pros, it's faster than working the old-fashioned way, and it's usually safer. The cons, price has to be taken into consideration. Sometimes the operator is an extra charge. Sometimes, for instance, in the state of Maryland, there's a highway use tax, meaning that you're going to drive down my road, i.e. State Highway, 61, with this heavy crane, you're going to pay $300. The rate charge is always portal to portal. That means when they leave the yard to when they get back to the yard. And then, of course, there are sometimes access restrictions, size and weight limitations. Whoop, too far. My favorite crane, of course, for most ham radio installations, i.e. less than 150 feet, is a Grove or a National truck-mounted crane. This can literally go anywhere. This can drive across any lawn without any quote-unquote damage at all. This is a 120-foot truck-mounted National that we use at K5MRs. This is an amazing machine. Believe it or not, this is a 160-footer, and it's pretty tiny. It's German, of course, so it costs probably $1 gazillion. Boy, was it slick. Here we are at K9CT. We're there in December. It was literally below zero. This was the first day, and it was so cold that this crane froze. So we didn't get any work done on that first day. Second day, we got an older crane, and it didn't freeze up. We were able to stack all the antennas in one day. Crane work is pretty easy. Puts up things like, this XM240, pretty simple stuff. Here's W2GD and myself. Again, we're at 110 feet. We're taking down an 8-element Telrex 15-meter Yagi. Big antenna. Here we are at K4ZAs installing some AB105. 2 lifts, 2 picks. Of course, if you don't want to go with a crane and you don't have such a tight requirement, you can do things like a man lift. There's all kinds of varieties of man lifts. This is a towable 50-foot man lift, i.e., it's so lightweight you can hook it up to your Toyota and bring it home. It's a 50-footer. It has an articulating arm, i.e., the boom is not just straight, it's articulating, as you can see. Here's a 40-foot articulating arm. This was used in a Charlotte location, as a matter of fact. In a minute, you're going to see us set in this tower. Here we are working between 2 of the Yagis. Here I am with a real crane installing that crank-up tower. That's an ITS crank-up. It's a 89-footer. It's a horse. And then, of course, you can do things like this. It's a little crazy, perhaps. It's me in a bosun's chair at 165 feet. And what I'm doing is replacing a broken coax, which is much, much faster, much easier than lowering the entire beam itself. Real easy to do. Most people think, boy, are you nuts? Anyway, let's talk about backing up a little bit and talk about working with concrete. Misunderstood term. Variety of tools are used and needed when you're doing concrete work. Measuring tools, woodworking tools, because of course, if you're going to work with concrete, you got to build forms. There's got to be a lot of metal working, because if it's a big base, you're going to be working with rebar. You're going to be working with water and concrete finishing tools and so forth. Ready mix is always preferred over mixing it yourself. Why? Well, most concrete bases are going to be specified at being 4,000-pound concrete, and Saccrete, which you can buy at Lowe's or Home Depot, is only rated at 2,000 to 2,500 pounds. And of course, mixing all that stuff is hard work. So again, a ready mix truck driving up, pouring it in the ground is the way to go. Proper curing is critical. It takes 28 days for concrete to reach its full strength. Keeping new concrete damp is always helpful. Working in cold weather, i.e. when it's freezing temperatures, is actually a good thing for concrete, which most people don't know. You should always add that curing time to your project schedule. Of course, 50 years ago, as I said, I put up a tower on Sunday that I poured the concrete on, Saccrete on Saturday. Amazing. Guy anchors for towers. There's only 3 acceptable choices. There are only 3 acceptable choices. Dead man anchors, manufacturer designs. For instance, if you get the Roan quote-unquote catalog, you'll see that there's several designs for dead man anchors. There's what are called screw-in anchors. Again, you want the manufacturer to approve them. And then there's elevated guy posts. You're going to be making this yourself. You're not going to go out and buy them, and you're going to need to get the PE to approve them, or again, somebody like me who's got a couple weeks of experience. You're going to go to the scrapyard, you're going to buy something, et cetera, et cetera. Unacceptable. And I say these are unacceptable because these are all things I have actually encountered. Jokingly, I'll chuckle over them now, but you don't want to have your tower guide to trees. You don't want to have a guide to fence posts. You don't want to have a trailer tie-down anchor. By the way, a trailer tie-down anchor is an auger that has basically a 3-inch screw. You don't want to do it to a building wall. You don't want to do it to abandoned cars or trailers. Here's a typical view of a dead man anchor. It's just a hole in the ground. build up with rebar and then concrete. Again, you can see that the quote unquote Roan guy bracket is down in there coming out of the ground, and it's the 45-degree angle. So that's the part you can get commercially, but you're going to be making that hole in the ground and filling with concrete, rebar and concrete itself. Here's the expanding earth anchor. The EQ plate and the rod screws into that hole in the top, and then you slam that down in there, and then that springs out, looks like a star. They're really, really pretty cool. All right, you should always have critical spares for your installation, meaning you should have a spare nuts and bolts for the tower leg and the antenna hardware, meaning, you know, there's, of course, say 4 U-bolts on that boom to mast plate. When you climb up there, you want to make sure you have at least 5 in your tool pouch, and have some extra nuts and washers. You always want to have enough rope on hand. You know, people always ask me, how much rope should I buy? Rope is expensive. Well, yeah, it is, especially good rope. And if you got a 100-foot tower, how much rope should you have? Well, I'd like to have at least 250 feet of rope. Well, gosh, the tower is only 100 feet tall. Yeah, but you got to go up and you got to come down. And then you got to put a pulley at the base of the tower, and then you have to pull that rope out away from the tower so nothing's going to fall, hit you on the head. And there's where the 50 feet comes in. Other common items that you should take along and have spares, coax and connectors, series adapters, of course, shackles, thimbles, and preforms. And you want to have ready access to your station notebook so you can make notes. And you do have one of these, right? I recommend that everybody have a station notebook. I prefer a paper one, not a computer one, for all kind of reasons. Anyway, there's some other things to consider.
Zach?
What is intercontinental?
We lost Don's audio.
Looks like he's muted.
I don't know. How about now?
That's good.
I don't know how
Good
that
now.
happened. I didn't do anything. But anyway, mount stacked matches at ground level. You mount your lightning protection devices, i.e. polyphasers, close to the shack and utility box. You follow single point grounding guidelines, of course. Ward Silver's books, a good reference for that. You should learn and practice good connector weatherproofing techniques. We'll talk about that in a minute. You want to do an annual tower inspection. That's cheap insurance, not only for safety reasons, but of course for performance reasons. Successful weatherproofing. I start with a Teflon wrap. The next thing I do is I will wrap a layer of Scotch 130C, which is linerless rubber. Again, the way to work with linerless rubber, it's covered in the box, but when you take it out of the box, of course, it looks black, it looks like tape. It has no adhesive or anything on it. It's just simply rubber. But if you pull it apart, you'll see that one side is just slightly stickier than the other, and that's the side that goes up. And you hold that end and you pull that until it changes from black color to gray color. Again, once you work with it, this is all just, you know, muscle memory, or, you know, easily learned. You wrap it around itself, 1/2 width overlap. You cover the 130C with Scotch 88 or Scotch 33. Again, you overlap 1/2 of the tape width. You use 2 wraps. You always cut, you never stretch or pull that last few inches. You always cut it with a knife or a pair of scissors, or if you're really, really good, you close your fingers and your thumb and you tear it. But you don't want to have any stretch on that last few inches. So otherwise it'll come off, you'll get flags, et cetera, et cetera. But I don't think I've had any known water issues in 30+ years, so I must be doing something right. I took N4, when K4ZA passed away, I took his station down And I took some connectors apart that had been up there that I know that I put up in 1989. So they'd been up for 14 years and they look like I put them up yesterday. So I have pretty good faith in that weatherproofing system. All right, you're putting up an antenna or tower? No, you're putting up a system. Again, back to that concept of system. It's an antenna installation structure or system. From concept through design and installation. You always want to follow good engineering practices. You want to use rated or quality materials, and you always want to make personal safety your priority during construction. Here's a couple of old fart pictures of W2GD and me. We worked together a lot. I thought I'd just run through some of these. Here we are, it's K9CT. We're building an element for a W3TX 4-element OWA. Here is a close-up of us at the top of that 100-foot, 110-foot tower, K5MR, taking down that Telrex 8-element. Here's John down in BP5JMs. Here we are at NR5M. If you have time, you can maybe go over and look at George's website. It took us 3 years to build George's station. Last time I counted, he had, I think, 25 towers. So it's a big station. Here I am, KC9QQ, again, crane work, putting up the antenna on top of the Trilon tower. There are questions?
Yeah, very good. I have a question. This is Lloyd N9LB, and I'll bring my camera back online here. This time of year, you frequently have people putting out, "Hi, it's spring. I need the balun changed up at the top of my tower. Is anybody willing to come help me?" I probably get about 10, maybe 20 of these kind of requests a year. My knees are going out, so I'm not doing too much anymore. But I wonder if we can get your advice on when you get volunteer tower climber help, what do you look for in somebody that you want climbing your tower?
Well, I'm not sure I can answer that because I've never done that or experienced that or had that. Obviously, you want somebody who knows, what they're doing, that has the right quote unquote materials, meaning you don't want somebody to show up with, an old lineman belt. You want them to have a PFAS system. Obviously, you want them to have some insurance. If anything, quote unquote, happens, untoward happens, you don't want to be calling your agent saying, "Is my homeowner's insurance going to cover, Bob who fell off the tower?" That sort of thing. So that's a tough question to answer.
Okay, thank you.
Ed, NMW, got a question. I did not hear you address the matter of attaching rotor cables and feed line cables to the tower.
That's true. I didn't talk about that. We can talk about that now.
Good.
First and foremost, if it's a big tower, i.e., something bigger than 100 feet tall, you're probably going to run heliax or hardline to mitigate feed line loss. And of course, in that instance, you're going to use a Kellum grip, at the top of the tower to hold the quote unquote heliax in place. If it's a tubular tower, i.e. Roan 55, 45, 25, et cetera, you can, bring the cables down, the side rail or the leg. You can use quote unquote cable ties to hold it in place. And of course, you always cover the cable ties with Roan, with Scotch 33 or 88 to again mitigate UV problems. If it's an angular tower, i.e. something like AB 105 or a Trilon or an AN wireless tower, that makes it even more difficult. because of course there's hardly any way to attach the quote unquote round cable to the angle iron. So what I do in those situations is use what's called a wire. It's just simply some number 14 or number 12 solid, which is, you know, again, there's a Kellum grip at the top holding the heliax. If it's regular coax, again, you know, I still would use the, well, you can put the Kellum grip on, you can put the Kellum grip on regular coax, RG215, but I use, you know, wire ties.
Hi, Don. Chris here. You mentioned the lanyard, double lanyard on your way up and down. So you clip one and then leave one on while you move the other one, or what's the technique for going up and down the tower safely so that you're always connected with your lanyard?
Yes, you do exactly what you just said. I'm not a fan of those big gorilla hooks, you know, that fasten to the D-ring in the center of your back. They just slow me down too much. So I use two lanyards, i.e., as I said, you know, both on the front, and one of them is it depends on the tower. For example, let's, you know, if we're talking about this, we should really mention that this is all of this is governed or guided by OSHA. They have specific guidelines for this. Specifically, that attachment point for the PFAS must be capable of sustaining a 5,000-pound load. Now, let's back up and say I've got a 25G 50-foot tower in the backyard. It's very simple. There ain't no point or place on 25G capable of supporting that kind of load. So what do? Well, the answer is the best you can, you go with a side rail with two welds, and you put your gorilla hook there. But on the bigger tower, like 45 and 55, you know, you're okay. But yes, the idea is to always have something hooked up. If you're using the lanyards, you know, you put one here and you put the other one a little above it, or one's below the other one, and you climb up and you move them, and you climb up and you move them, and you climb up and move them, yada, yada, yada.
Okay, thanks.
Slow going, even slower coming down. Fortunately, you have gravity working to get you down. That helps.
Don, K3Q here. We have the standard Roan 2545 gin pole. What can you use on 5565?
Something bigger.
And they
EF 2545 is rated for 70 pounds. That's it.
Does Roan make a bigger one, or what do you use? Make your own?
I have a custom made gin pole, yes, which I made.
Okay.
Is that it?